Today I really like today's worksheet. I made it up myself. So basically you are doing this, but also just looking at a graph. Okay, so you can use your calculator if you want to, but all the graphs are pretty similar today. And hopefully you'll just catch on to what the shape looks like. Okay. This one is a parabola?
Oh wait, no, I didn't mean.
Yeah. All right. So just to review here, we want to try to factor and solve. So what do you notice about these three terms? X can come out. All right. When I take out the X, what's left behind? Minus 28. Good. Okay. And then we can factor that trinomial, the leftovers there. Factor the leftovers. What times what is X squared? X times X. And then last times last has to be negative 28. What do we get? Positive 7, negative 4. Very good. And then how do you actually do the solving part? Set each thing equal to 0. So we set the bubble, X plus 7 equals 0, and then move over the 7 so we get X equals negative 7, and then X equals positive 4. Okay. So I'm glad you know how to do that because that means everything will be really easy. What we're going to be doing then is plotting these x-intercepts. Okay. Plotting these x-intercepts and then connecting them in a nice smooth curve. This is a cubic, which is an interesting shape. I love when we call it a squiggle. All right. So let's do some subtracting. Example 1, find the zeros by factoring. Sketch the polynomial, label the intercepts. Find the zeros by factoring and solving. Sketch the polynomial and label the intercepts. Label the intercepts is not specific. That includes X and Y intercepts. So this is going to be a good review, hopefully. Sorry. I did explain it.
Yeah, I was actually writing exactly what you said.
Good enough. Good enough. All right. Find the zeros by factoring and solving. And sketch. Yeah. All right. I have, you'll notice the y equals part here. When we have x's and y's, it turns it into something graphical. All right. Something that we can graph on an x and a y axis. All right. And so when the y is there, this is something you can plug into our calculators really easily. Okay. You all have a y equals button on your calculator, and you can look at it if you want to. To find zeros is a very special word. Zeros occur when y is equal to 0. That's why it's called zeros. It's also fancy language for x-intercepts. So if I want to find the zeros, then I set y equal to 0, and I can factor.
Really? So that's why we always set it equal to 0.
It's because we feel like a Jonah. Don't put labels on it.
Anytime you set it equal to 0, you're finding an x-intercept or 0. Same thing. All right, so we're going to factor. How does x squared plus 4x plus 3 factor? X plus 3 and x plus 1. And then we get to set each bubble equal to 0. And so we get x equals negative 3 and x equals negative 1. And what we just found were the x-intercepts. Okay? These are x-intercepts, negative 3 for the x-coordinate, and we plugged in a 0 for the y-coordinate. So what we've really got here are the zeros, or the x-intercepts, also known as. Okay? When you're solving for x, you're solving for x-intercepts. Okay? Very interesting. Or intersection points, depending. Okay. Now, the label the intercepts, I also want to be able to find the y-intercept. How do you suppose,
Set x equal to 0?
yeah, the y-intercept, we're going to set x equal to 0 and then figure out y.
Figure out.
Well, that's pretty easy, so figure out y. Okay. So in this form, this is really, really nice. If I plug in a 0 for the x's, what do you get? 3. This constant on the end always happens to be a y-intercept. The y-intercept happens to be, if you plug in a 0 for the x, you get a 3 out for the y. Okay? So if you have a constant, that's the y-intercept. Kind of nice. So I'm going to go ahead and plot these. Make a very simple sketch here. Very simple. XY chart. I'm going to go ahead and label I'm not going to draw tick marks. Don't bother. It's a waste of time.
Oh, roasted.
Okay, so I'm plotting and labeling. No one can dispute you if you just plot a point and label it. Okay, so x is -3 and x is -1. And then I also want to plot my y-intercept, which is at 3 on the y-axis. What shape is this function? Parabola, yeah. So it's a parabola, and it's an up parabola. All right, and so it passes through those 3 points. I kind of missed on my y-intercept there, so I'm just going to adapt it there. There we go. All right. There it is. There's your parabola. Can you use your graphing calculator to check? Yeah, absolutely. Okay. If you do not have a graphing calculator, you need to go bother the finance office because they have 40.
Seriously?
They did.
You should announce that during the PSAT, so all these like freshmen I saw that were like sitting there like, oh gosh, I might need 2 + 2 without the
All right. Second one here, we want to find the zeros. So I have 0 equals -2x squared plus 32. What do you notice about those two terms?
No middle term.
No middle term. Also,
Multiply it by, GCF of -2.
a GCF. There is the greatest common factor. We're going to factor out the -2. When I factor out the -2, what is left behind?
X squared minus 16.
X squared minus 16. All right, and then again, we can double bubble. How does x squared minus 16 factor?
X plus 4 and x minus 4.
Good, x plus 4, x minus 4. And then we set each bubble equal to 0. Well, I'm going to try to set the -2 equal to 0. Can -2 equal 0?
False.
Never. You get to ignore him for now. This one we get to set equal to 0, and we get x equals -4. And here we get x equals
4.
positive. What's the y-intercept? 0, 32. Very good. All right. Now that constant is right there. And then I can make a quick sketch. So here's -4. And here's +4. And here is 32. Is this an up parabola or a down parabola? Down parabola. We know it's a parabola because of the x squared. We know it's a down parabola because of the negative. So I'm just going to connect those in a nice smooth U shape. It's not a V, it is a U shape. Do not make a pointed parabola.
32 is
How do you make
It
one
is.
of parabola?
I just
Yeah, mathematically, how do you make a point of problem?
You know, it's called absolute value. Different function.
So it's like a parabola but absolute.
It's an absolute value V. It's the shape of the graph. It's not a parabola at all. Yeah. All right, couple more here. Isn't this fun? Let's see. I don't. No. Okay. I guess we will. All right. Letter C. Y equals -10 plus 12x minus 2x squared. What's the issue with this one?
Out of order.
Out of order. It's a little backwards. All right. So, do we want to rearrange?
Yes.
Yeah or no? It doesn't matter. If I were to rearrange it, how would I rearrange it?
Negative 2x squared.
Plus 12.
Good. All right, now what do you notice?
GCF.
GCF, very good. So I'm going to set it equal to 0 and take out the GCF. What is the GCF?
It's a common factor.
That's true. Okay. When I take out the negative 2, what's left behind?
X squared plus minus 6x plus 5.
Very good. All right, and then we can factor further.
X minus 1 plus 5. Minus 5.
There you go. X minus 1 and x minus 5. Negative 1 times negative 5 gives me my positive 5. So we get solutions for solutions for x of
1 and 5.
1 and 5. All right. What's the y-intercept?
That was -10.
0, negative 10. Very good. Right there, there's that negative 10. And it comes because we actually plug in zeros for x. Easy to get. All right, little sketch, quick sketch. I've got a 1 and a 5 and a negative 10. Is this an up parabola or a down parabola? Down parabola. Again, we know it's a parabola because it's x squared. Because of the negative in front, it's an upside down parabola. So it looks something like this. Okay.
Negative is a positive.
And it's supposed to be a positive.
Oh, I mean.
Wait, the GCF. Yeah, okay. All right. So what shape is this one?
Squiggly.
A squiggle. It's not a parabola. That's what it's not. Okay. This is x cubed. X cubed is a little squiggle. It's kind of an interesting thing. What is the y-intercept here? 0. Yeah, there is. I mean, the thing that's added on the end here is a 0. So it turns out it's, I think it's called a double intercept. It's an x and a y-intercept. So we'll talk about that again here. All right, we want to find the zeros. So I'm going to set it equal to 0. What can I do here to factor?
GCF of x.
GCF of x. Very good. So we're going to take out an x. Is this moving fast for you guys, or are you okay? If only it can move faster. Word. Okay. What's left behind?
X squared plus x minus 6.
Very good. And then we can double
X
bubble.
minus 2x plus 3.
Good. X minus 2 and x plus 3, which means what are our solutions for x?
0, 2, negative 3.
0, positive 2, and negative 3. Very good.
So is that the first 0? Is that where we?
So I'm going to plot my points first. 0, and here's negative 3, and here's positive 2. So I'm going to plot my little zeros there. Now, this is a cubic. This leading term, just like here, my leading term, whatever the highest power is, tells me a ton of information about the shape of the graph. Now, because it's a positive cubic, positive means it's going uphill from left to right, all right? So it's going to start low on the left and end up high on the right, all right? What happens is it passes through each 0. Passes through the furthest left 0. It has to turn around to pass through this one. And then it turns again to pass through, it is a roller coaster, to pass through the 2. All right, so we can check this on y equals x cubed plus x squared minus 6x. Pretty cool, right? Okay. All right, so let's try one more of those.
What was the y?
The y-intercept, so this is not only the x-intercept, but it's the y-intercept as well. 0, 0. Yeah. All right, last one. Here we go. Y equals negative 2x cubed minus 10x squared minus 8x.
GCF -2.
Good. We have a
X, negative 2x.
negative 2x. Very good. Negative 2x is the GCF. That leaves behind what?
X squared
X squared
plus
plus
5x plus 4.
Very good. I'm purposely taking my time here because I want you guys to be working ahead of me. It's brilliant. So then the double bubbles into what?
X plus 1, X plus 4.
Good. X plus 1 and x plus 4. Which means
Ooh,
I get, what are my solutions?
0, negative 1,
0,
4.
-1, and
Good. So I'm going to go ahead and plot those. 0. Here's a negative 1. Oh, and here's a negative 4. Lopsided. Okay. All right. So here are all of my x-intercepts. Again, looking at this leading term, it's a cubic squiggle, but it's got a negative in front. What do you think that's going to do to it? It's going to go downhill from left to right. So it's going to start up high and end down low on the right. High on the left, low on the right. So it starts from up top, pass through the furthest left 0, turn around and pass through, turn around and pass through.
Do they always have to go to 0?
Well, for these they will. For these cubics, they will. Do you have questions for me? Yeah.
Doesn't matter.
Well,
No, how deep your valley is or how high your mountains, I don't care about.